right, today we're going to continue our lesson over transformations, and today we're going to talk specifically about reflections. There's going to be a lot of slides today where I ask you to hit pause and to kind of work through and process on your own, and then to rejoin me and check your answers. So if you will make sure you take the time to do that instead of rushing through, you will have a better understanding of the lesson. All right, so today's objective is to perform reflections and go. All right, so we're going to start this lesson by reflecting points over the x-axis. So if I take point A and I pick one of my colored pens and I reflect point A over the x-axis, so if you think here that this is the x-axis and here's point A right here, this is 7 units above the x-axis, so I'm going to move that 7 units below the x-axis. And this is going to turn into point A prime. So I'm going to mark that A prime. So go ahead and hit pause, and I want you to see if you can figure out the other 4 coordinates and then think about the patterns in x and y and come up with a rule. All right, welcome back. So if you did this activity, this is going to be 4, -7. B turned into the point to -3. C turned into -7, 9. And D turned into 9, 4. So when I look at the patterns in my x-coordinates and I compare my x-coordinates of each of those points, the one thing I noticed about the x-coordinates is that there was no change. Those absolutely 100% stayed the same. Now, when I look at my y-coordinates and I compare those two y-coordinates, 7 went to -7, 3 went to -3, -9 went to +9, and -4 went to +4. So my y-coordinates actually changed signs. So if I had to think of a rule, my x value stayed the same and my y value changed signs. So every time I reflect over that horizontal x-axis, the x value stays the same, so you travel left or right the same distance, but then your y value will change sign. All right, so now pick a different color pen, and I want you to reflect the points this time over the y-axis. So this time, we are reflecting points over the y-axis. So if I take point D right here, and I reflect it over the y-axis, I'm 1, 2, 3, 4, 5, 6, 7, 8, 9 units away. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 units this way, and that's going to give me my point D prime. So my new point D prime is going to be 9, -4. So at this point, or D double prime, because we already had prime, so that's why I marked these double primes right here. So now at this point, I want you to hit pause, and I want you to answer the questions 4 through 6 after you find the coordinates of the points. Okie dokie, welcome back. I hope you learned something. So let's see if you figured this out. So if you reflected point E, you should have the point 6, 0. And when you reflect point F to get point F double prime, you should have 0, 8. And when you reflect point G, you should have +5, -5. So this time, when I look at my x coordinates, so to go from x to x, I have a typo here. I'm stuttering. So here you have a negative. That should have been a -9 because I went to the left. So I went from +9 to -9. Here I went from -6 to +6. 0 has no signs because there are no signs associated with 0. And here I went from -5 to +5. If I looked at my y's and I compare all of my y values from these 4 points, nothing happened to my y values. So in this particular case, my x values changed signs, and my y coordinates stayed the same, so there was no change. Whoops, I'm having all sorts of problems today. Okay, so if I think about this rule, my x value changed signs, and my y value stayed exactly the same. Okay, moving on to the line y equals x. So I want you to go and let's all plot a couple points. This is called the line y equals x because my y value and my x value are always the same. So I want you to plot these 3 points. I want you to plot the point 2, 2. I want you to plot the point 5, 5. And I want you to plot the point negative 3, negative 3. And naturally, this line will go through the origin. And so make yourself a nice little dotted line that goes through all of those points. It will also go through point G down there. And this is the line y equals x. So at this point, I'm going to go ahead and tell you what the rule is for y equals x. So the rule for y equals x is the point xy goes or becomes the point yx. So essentially for this, the x and the y just switch locations. So if we think about this visually and analytically, and we look down here at point A, if I look at point A and I say, okay, I have the point 4, 7, it's going to become the point 7, 4. So if I graph point A, I'm going to go over 7 and I'm going to go up 4, and I have the point A prime. Now, one thing to note about these 2 points is that if you actually connected them, this distance here and this distance here are the same, and the purple line and the blue line are perpendicular. So the line connecting A to A prime and the line y equals x actually will form right angles. And this is true of every y equals x reflection. All right, so moving on, if I have the point negative 7, negative 9, it becomes the point negative 9, negative 7. So here's point C. So I'm going to go negative 9 and negative 7. And right here is the point C prime. And then the point negative 6, 0 becomes the point 0, negative 6. So I'm looking here at point E. And here is point E prime. I'm going to use point E and E prime to show you the whole perpendicular bisector thing. So if you happen to connect E and E prime, these 2 distances would be the same. And then those 2 lines are perpendicular, so there are 4 right angles formed by those 2 lines. So we also have the line y equals negative x. So if we think about the line y equals negative x, if I have the point 2 and y equals negative x, I'm going to have the point 2, negative 2. If y equals negative x, I'm going to have the point 3, negative 3. And if I started with a negative, like negative 5, and y equals negative x, I'm going to take the opposite of that. So take a minute and plot these points on your graph so that we can establish the line y equals x. And once you've plotted those points, you can draw a diagonal line through them. Your line will go through the origin. However, your line will not go through the corners of the graph. Now, if we think about the rule for y equals negative x, where y equals x, the 2 coordinates switch places. When you have y equals negative x, not only do they switch places, but they also switch signs. So if I take my first coordinate here and I have negative 2, 3, negative 2, 3 will switch places. So 3, negative 2, and then both signs will change. So if I'm looking here at point B, so right here, and now I plot point B prime, I have the point negative 3, up 2, and that is going to give me the point B prime. So now, applying the rule to point D, these 2 points are going to switch places, so negative 4, 9, and then both signs will change. So if I look right here at point D, and now I graph point D prime, I'm going to go over 4, and I'm going to go down 9. So this is going to be the point D prime. Now, like last time, if I were to connect these points, these 2 segments would be congruent and these angles would be right angles. That's one way you can check yourself and make sure you are correct. And last but not least, we have point F with coordinates 0, 8. So this would become 8, 0. change both signs. Don't really need to change the sign to 0. So, and point F is up here. So now if I come over here, 1, 2, 3, 4, 5, 6, 7, 8, and I go to -8. I don't think I went 8. 1, 2, 3. Nope, I was 1 short. Okay, so go to -8. Don't go to -7. And this is going to be point F prime. And one more time, if I connect F and F prime, not E and E prime, if I connect F and F prime, what will happen is you will have perpendicular lines with congruent segments. Okay, moving forward. I want you to hit pause, and I want you to go ahead and do the next 8 problems on your own based on the rules that we just established. When you have all the problems done, rejoin me and you can check your answers. All right, welcome back. So when we reflect the point A over the y-axis, so if I think about reflecting something over the y-axis from here to here, it's my x value that changes and my y value stays the same. So my y value stays the same, but this time my x value will change. So reflecting in the line y equals x. When I reflect a point in the line y equals x, simply what happens is the 2 coordinates change signs. If I reflect a point over the x-axis, and trust me, I am not afraid to draw these pictures because it really helps me visualize what's going on. When I reflect a point in the x-axis, the x-coordinate stays the same, and the y-coordinate is the one this time that changes signs. And then when I reflect something in the line y equals x, this is one of the few rules you'll just have to memorize. You switch the coordinates, and then you change both signs. So if we do more than one transformation at a time, we can do that. These are called compositions of transformations. So if I have some point over 3 up 1, and I reflect it in the x-axis, my x-coordinate stayed the same, and my y-coordinate changed. So now I'm down here. And now I'm going to reflect that in the line y equals -x, which means the coordinates change locations, and then the 2 coordinates will change signs. Moving on to number 6. If I reflect the point -4, 5 over the line y equals x, that's going to give me f prime, which will be 5, -4. And then I'm going to reflect my new point, f prime, over the line y equals -x to get f double prime. So now I'm reflecting over the line y equals -x. So now they switch locations, but they also switch signs. All right, so last but not least, we have a triangle, RST, with the stated coordinates. Reflect the figure over the line y equals x. So when I reflect that over the line, that figure and these points over the line y equals x, I'm going to get 3 new points. My rule for y equals x says that if I have point xy and I reflect those points over the line y equals x, the y and the x simply switch locations. I encourage you, when you reflect figures, don't reflect the whole figure, reflect the vertices and then connect them. So we have 8, 8, and if you switch them, you still have 8, 8, because y equals x. S, you had -9, 2. If those are flip-flopped, you get 2, -9. And t prime becomes -7, 3. All right, so I want you to go ahead, and we're going to stop right here. I want you to work on your homework. When you get to the point in your homework where you are reflecting over a line that is not the x-axis or the y-axis, that's when you need to go back and you need to watch the next video. So I have done a little separate video for this because it's a little procedural. So when you are reflecting a figure or points over a line that is not the axis, so it's not the x-axis or the y-axis, then go ahead and watch the next video in the series. It's 4.2b, and we will talk about how you can do that. So you can either count them or you can use a little mathematical procedure. All right, hope you have a great night, and I look forward to seeing your bright, shiny faces in class tomorrow. Bye-bye.